Okay, quick summary along with a new question. We're looking at stretching transformations, geometric stretching transformations. We start with a function y equals f of x equals x to the p, a power function, for an unspecified number p. And we then increase the y value at every point. For every x we have a y value, we increase that y value by 25%. So we can do that geometrically. We could use a compass and straight edge to bisect this interval here to get this interval, and bisect that interval to get this interval, and this interval would be 1/4 as great as this interval. Since this interval represents the y value, this interval plus this interval gives us this interval, okay, which represents a y value 25% greater than the original. We can do the same for any number of points along the curve, although we can't do it for all points because there are an infinite number of them on any small interval. So we don't have time to do that, but we can do that and get representative points, and then we can approximate the curve. We note that the new function, which we call g of x, gets progressively further away from the f of x function. We ask, why is it that the graph of g of x, in this case, keeps getting further away from the graph of f of x as x increases? Now, this won't always be the case for any function, just any function f of x. If the function isn't increasing, this won't happen. But for this particular function, why is it this happens? Can you explain in simple words and give a simple explanation for why it's so? Okay, so other thing now, what's the formula for our g of x function? Well, we come down here and reason that out. 25% more than y, and this is an important statement here. 25% more than y is y plus 0.25y, and we should understand that very well if we understand percents. And if we don't, we better review it and make sure we understand percents a lot better than most people do. We can take this expression, factor out the y, we get y times 1 plus 0.25, which is 1.25y. So 25% more than y is 1.25y. Another way of saying that would be 25% more than y is 100% of y plus 25% of y. That would be 125% of y, which is 1.25y. So we can think about it in a variety of ways. So if y equals f of x, 25% more than y is 1.25y, which is 1.25 f of x. And it follows then the g of x is 1.25 f of x, because for every point on the graph of f of x, the graph of g of x has a y value that's 1.25 times greater. That's greater by a factor of 1.25. What I said before was correct, but let's use the terminology very clearly. F of x changes by a factor of 1.25, a factor being something that we multiply. Okay, we want to be careful about that terminology because we want to contrast this in a minute with a shifting transformation. Okay, now I make the comment, the terminology, that we've vertically stretched the graph of f of x by factor 1.25 to get the graph of g of x. This is what we mean by vertical stretch, as if we took the y-axis and stretched it out to, all y values, stretch them out by 25%, we get this. Okay, now there's an additional question, but I'm going to put that on a very brief subsequent video. You can welcome to read it.